Okey, speaker dan selamat petang. Terima kasih Dr. Tamrin. Terima kasih kepada Dr. Mazlaini. Okey, so kami minta maaf, dekan ada masyarakat yang lain. So saya mewakili dekan mengucapkan terima kasih kepada Dr. Mazlaini atas kesediaan untuk memberikan sesi perkongsian pada hari ini. Dan semoga akan ada kerjasama di antara fakulti kita dengan Petronas lah, insyaAllah. So, tanpa bermasa, saya serahkan kembali kepada moderator, Dr. Tamrin.
Okey. Assalamualaikum warahmatullahi. Selamat tengah hari, salam sejahtera. We are very grateful today because we have our guest, Dr. Mazlaini Yahya, who is a staff researcher at Petronas R&D. She has been doing as joining for 4 years. For how many long been joining the Petronas R&D?
End of this year, 5 years lah.
Oh, 5 years. Okay. Also, I just read through this brief. He provides the technical expertise in the field of electronic automation, high-speed wireless and wired network communication, the hardware design, and programming. Dr. Mazlaini has a bachelor degree in electrical engineering and Doctor of Philosophy in solid state physics, optical physics, and optoelectronics from Purdue University and UITM. He got 3 PhDs of this research, and I learned that he is doing the 4th one. Is it, Dr. Mazlaini?
Yes.
Yeah. He has over 29 years of industrial research and technical experience in solid state and optical physics, semiconductor technology, integrated circuits, electronics, radio frequency, and optical transceiver design and communication networks. Okay, so the presentation is, without further ado, it's over to you, Dr. Mazlaini.
Okay, thank you, Dr. Tamrin. Let me share my presentation here. See. Okay, so everybody can see my pack, right? Does it appear on the screen? Okay. Wait, hold on. Wait. Let me share again. Stop. Let me share again. Computer. Okay, so Assalamualaikum and a very good afternoon lah to my distinguished audience lah from Universiti Malaysia Sabah lah. So before I present ni, actually the title of this topic ni is about network communication lah, how to address the issue of connectivity, and then we don't get the data speed and so forth lah. So the name of this technology, we call it virtual optics long haul asynchronous network technology. Before this, we used to name it very high speed offshore lah, because we designed this technology ni for offshore communication. So let me provide you some history lah. I started with this development ni during COVID lah, back in 2021. At that time, right, we have to stay at home. But for me, I have to come to office lah, because my home is very near to the office. So this is where I start to develop this solution. Because currently I'm leading the automation group lah under Petronas Research. So my job is to come up with a solution that address the issue of to provide connectivity for our IoT, for our digital application. So I saw the problem lah in all of this digital application is the communication, especially network lah. And for Petronas is offshore lah, because we don't get the connectivity and we have to depend on satellite communication. So I come up with this technology lah. Why not we try to come up a solution that we can still use the current infrastructure. So let me start with give you some introduction. Okay, there's a video here, VOLANT. I hope you can hear. Okay, so that oops, so that's give you some demonstration what is all VOLANT about. VOLANT actually is a internet channel bonding. So please stop me lah if you have any question. I like to have like interactive kind of presentation lah. So at least I can give you more clarity of the solution. So as you can see, VOLANT is actually is an internet channel bonding. So the difference between this method is that it use what we call this current or existing network infrastructure lah. So you know that current infrastructure we have limitation. So it's very hard for us to kind of make improvement lah with the physical limitation. So another method is why not we take one level up rather than we focus on the physical. Why not we go into the virtual level? So that means we can achieve the what I call it desired lah, data speed and also the what I call this connectivity quality and also the reliability of the network lah. So as you can see from this presentation, I put the points lah. Okay, what is VOLANT is all about? It's an internet channel bonding. It provides multipath internet routing. It provide what I call this? It performs inverse multiplexing of internet transmission. It also try to overcome data speed limitation by using a lot of all these channels and process it at virtual layer. And then the unique about VOLANT is that it is a single client device lah. It doesn't have any pair or it does not require any server. Because of this technique, then it can what call this achieve what we call this non-aggregated network, non-load balancing network, non-load shaping network, and it can also address unequal channel if you want to mix channel that with different performance. And the main idea of VOLANT is that from what call this user data, it will try to split the packet into many paths so that it can enable what we call this unlimited network hops and also can improve the channel by what call this improving the latency and also the reliability. So when we started this back in 2021, we did some what I call this pilot test in Langkawi. I think somewhere in early January, February 2022. So we managed to get gigabit wireless transmission from Langkawi to Sungayan using 4-channel DMR. So that's about like 80.7 kilometer. As you know, that there is a what I call this regulation in terms of the bandwidth that you can use to transmit what I call this over 1 kilometer. So usually the bandwidth that we can use is about 30 megahertz bandwidth. So if talking about 30 megahertz bandwidth, the maximum data speed that you can achieve typically about 300 Mbps. So in order to get that gigabit, it seems impossible with the current setup. So we have to overcome that scenario by bonding multiple channel of the DMRs so that we can achieve the gigabit transmission. So the idea of VOLANT is, I can put the ideas is what we call this infrastructure sharing. So the idea is that if you have say like multiple premise that within the transmission range, so you can use the infrastructure by sharing what we call this the data speed, the infrastructure cost, and so far, so that you can extend the network coverage. So this is how VOLANT function. That means it will take the normal data packets from say a router. So it would try to split the data packet into many paths, and in the path it depends on the destination of the what you call this data packets. So we have tested VOLANT on multiple medium, on satellite, on digital microwave radio, and also through what you call this port network. So the beauty of VOLANT, it can combine all these three different mediums, and you get what you call this increase in data speed, and also you improve the latency. So currently VOLANT is capable of what you call this doing internet channel bonding up to 100 gigabit per second, and it can be unlimited number of channels, and irrespective of what type of communication medium, it can be wired, it can be wireless, and it can be optical connectivity, and VOLANT is able to do the bonding. Okay, I give you a scenario lah why we develop the VOLANT technology lah. The idea is like for our offshore operation, we have this problem of range lah. Sometimes we have this obstacle because of the uh, elevation that is currently available at the platform. We don't have the actual elevation, so that can be a problem when we want to use the MR. So we have to do something with the MR configuration. One of the method, if we want to increase range, we reduce the bandwidth so that we get more power for the range. But then when you reduce the bandwidth, you reduce the data speed. So which is not a good what could this best scenario lah. So because we need the data speed, but then we have to sacrifice the bandwidth, so we need to find a way how to address this problem. So we design the VOLANT so that we can reduce the bandwidth, at the same time we can still increase the data speed by combining multiple of the MR channels. So with this what call this solution, so irrespective of the range, we can do a proper configuration. If we have a very long range, okay, we reduce the bandwidth, but we also reduce the data speed. But then to overcome that data speed reduction, we just add multiple DMRs to compensate that data speed loss. So this basically the idea why we design VOLANT, particularly last time for digital microwave radio. So just give you some scenario like what we did at between Langkawi and Sungayan transmission. So VOLANT actually is a client device. So it will try to combine multiple channels to get the desired data speed. As just now I mentioned that VOLANT can go up to 100 gigabit per second in terms of channel bonding. So just give it a scenario how we what we did for our offshore communication. As you can see, like from on offshore to say we need to get internet connectivity from onshore. So if we have a multiple DMR channel, so the speed is actually like accumulation of the each channel. Say for example, like in channel A, you achieve 350 Mbps. channel 2 350, and then channel 1 300, channel 2 350, channel 3 350. So you sum it up all the total channel capability. In case of data speed, we can get up to 1 gig, like 350 plus 350 plus 300. So that is the best scenario. But unfortunately, because we're talking about physical, there's always an overhead. So VOLANT has a overhead about like 10% lah, for wireless medium and 5% for cable medium. So let me skip this. Just to show why what call this VOLANT is unique compared to other solution, that it can address what we call this unequal channel performance. So with, for example, if you have a 100 Mbps on one channel and you have another channel that is very low speed at 10 kbps, VOLANT will try to utilize that what I call this slow channel. So that's the beauty, and people will say, okay, why you already have a high speed channel, why you want to use the low speed channel, right? So the the main function is something like this, is for reliability lah. We have a scenario in one of our offshore. We have one high speed and suddenly that network is down. So, and if you don't use that what I call this redundant channel, sometimes you know, like a typical hardware, right? If you use that long, you will try. It remains so what I call this idle for so long, it won't what I call this function at the moment that you really need what I call this that network lah, to provide the backup and also the fallback lah. So VOLANT will ensure that all the channels being connected to VOLANT, even irrespective of the speed, continuously used. So let me give some different example of configurations where we can use VOLANT. For example, before this, I showed you about infrastructure sharing. That means you can hop between different sites. Talking about infrastructure sharing, right? If you want to have infrastructure sharing, that means your data speed has to be very fast. If not, it defeats the purpose of infrastructure sharing. So this is one scenario that you can, what I call this, increase or extend your network using DMR. And you can use multiple DMR channels, and you can hop between many sites. You can combine DMR with 4G as a what I call this fallback. You can use 4G and 5G scenario, what I call this as an internet source. This is to overcome line of sight. That means you can put a line of sight relay so that you can extend that network connectivity, network coverage. This is one other example for line of sight relay. That means you extend the coverage on what I call this high terrain site. For highland hopping, this is basically we design VOLANT for offshore hopping. And we also have deploy what we call this marine broadband from on offshore platform to a moving vessel. So currently VOLANT has achieved a commercial status. So we have deployed a number of sites. See, currently this is one of our site at Westico Field. About what 200 kilometer from Kete. So we have all these multiple hopping between our platform, from Angsi to Berantai to Tembikai, Jitang, and Ledang. Ledang is the moving vessel. It's actually a moving platform. So all this site we achieve about 300 Mbps downlink and 300 Mbps uplink. So you can see in the what I call this speed test. That's where we did the speed test at Ledang and also at Tembikai. We already did some tests, I think, in somewhere last year in Tawau with Sabanet. We combined to Starlink. So this is the speed that we get by combining two Starlink client using multi-band Starlink. You almost like double. And then currently we have a commercial deployment using two premium package Starlink at our Chendol field. So we achieve about like between 400 to 500 Mbps. So this is the list of current deployment. We have one rural deployment in Pulau Sebatik for SK Wallace Bay. We hope that to complete this, I think, somewhere after Hari Raya. And then you like to know, okay, where is VOLANT actually? VOLANT actually is a router that we develop the algorithm to enable what we call this channel bonding with unlimited number of hops and unlimited number of bonding channel. But unique thing about VOLANT is that it is a single client. That means it does not need a pair like uh, normal solution or a server to do what we call this data packet realignment. When you split the data packet, you need to recombine it back, right? So you need a controller. So VOLANT does not have that controller. So we also have our own what we call this dashboard to monitor and also to do auto configuration for all the VOLANT devices. I'd like to present you some of the VOLANT use cases. For example, I mentioned you can have a multi IP DMR. You can have multi IP DMR with multiple network hop, multiple 4G and 5G ISP. We already successfully conducted this in our what I call this Petronas Research site in Bangi. You can have multiple band or multi ISP satellite. Already did this for Starlink. Currently, we have the site at what I call this Tembikai. A lot of all these lists and our clients like Vestigo, Nippon GX, Petrofac, Hibiscus in Sabah. And because of the technology is so unique because it's a standalone single client, so we managed to use the technology for what we call this Wi-Fi mesh network. Enable data speed along all the mesh nodes, unlike what I call this normal solution for Wi-Fi mesh. So okay, just to show where you can do channel bonding for multi 4G and 5G network. Currently, we are having this kind of test for mobile vehicle, so that actually you can address the issue of for autonomous vehicle that you need this consistent high speed data connectivity. Well, also I mentioned that it can go up to 100 what I call this gigabit per second, right? So it can address most of all these issue for unequal channel performance. Even though you have very low what I call speed channel and you want to combine it, so what I call this VOLANT is capable of doing that. This is one of the scenario for like you want to use for like to control your drone for long range what I call this coverage. This to show you we did a test using what I call this VOLANT to show that how it use the how we address this unequal network path lah. So we have combined 3 channels, one with 10 kbps, one with 100 kbps, and one with 1 mbps. So we did a what I call this speed test. So you can see that from the chart it utilized what I call this the the channel all the time. This is one of the use case which you want to combine your fiber optics network for long range. Okay, just to recap, okay, what is VOLANT capable of doing is that we can do this long haul backhaul network using DMR, and also we can combine with satellite com, and then with that connectivity we can extend for the last mile. This is one another scenario using 4G and 5G for building a vehicle, and then we can extend that internet connectivity for indoor coverage using Wi-Fi mesh network enabled by VOLANT. Okay, this is the scenario that we are currently deploying for our offshore platform. Once we get the data platform, then we use Wi-Fi mesh to provide the last mile coverage throughout the platform. This is currently we have a deployment in our site at Bangi, which we can cover the whole campus, outdoor and indoor, using only wireless mesh network without any cabling. Just to show, because of the unique of and that means you can have multiple path just from the to connect to the internet. If you look the current setup for most Wi-Fi AP, right, is only one path, but for VOLANT you can have multiple paths so that you can address the issue of coverage for, like, you have multi-level indoor building, underground, and to provide what you call this self-healing in terms of network reliability. And this is one of our use case if you want to if you want to cover, for example, and I think that's about just I need to show you. I think I have one video here. If I'm not, if I have, oops, okay. This one I didn't play the what I call this the video here. Maybe I can show you. Okay. As you can see, VOLANT we have like one network, 1, 1, 1, 2, 1, 3, and then you can see the graph, the traffic. It consistently utilize all the path for download and also for upload. So as you can see, right, 1, 1, 1, 1, 2, 1, 3, and then the VOLANT is the summation of 1, 1, 1, 2, and 1, 3. I think that's about my presentation. So I open up to question.
From the audience, maybe can raise any question about this VOLANT technology. Um, this is what I observe because it, especially in Sabah lah, where there are lots of terrain, monsoon, some apa ni, kemudian rolling out the fiber optic is very costly when apalagi kawasan yang the rural area where the market is not there. So I think because you have a solution for the backhaul, the backbone, so it can save lots of fiber optic cost per to implementation quite big
Yes.
because you need that fiber optic because the cost of fiber optic is not really not cheap and very expensive. So that is the we can say the substitute of solution of the fiber optic backhaul.
Okay,
Am I
maybe
right?
maybe I can add like something like this lah.
Yeah.
When you want to have a gigabit lah kan, gigabit data speed, right? So the only solution that you can think is fiber lah, right? Fiber optics. But then fiber optics, the problem is not just the cost of the fiber optics, but also the deployment lah. You need right of way. That means tuan punya tanah lah. We need that permission. It's very difficult. And then the other issue is the terrain lah. Right. We don't apa ni lay fiber optic cable to high terrain because it's too costly, right? And then easy damage lah by the what you call this by the nature lah. So we need to address that problem. So but then another solution to overcome this obstacle lah is wireless lah. But then we are limited by wireless physical limitation. MCMC they put not just MCMC lah, our SKMM, right? It's like all over the world lah. They have this regulation for any wireless transmission over 1 kilometer, right? You cannot have bandwidth more than 30 megahertz per channel. The same goes for satellite as well. And then some country they allow you up to 50 megahertz, but most country they allow you up to 30 megahertz because they don't want to introduce unnecessary interference lah. Okay. And then we're talking about 30 megahertz ni for microwave ni. You have limited data speed lah, right?
Yeah.
So 30 megahertz is equals to about 300 Mbps, not near to gigabit, right? So
Yeah.
how to solve that problem? So we said, okay, why not we combine the MR channel lah, so that we can achieve gigabit. So with VOLANT ni, we already showed, okay, we already achieve gigabit. Now that the selling point is that we can solve the rural connectivity problem lah, right? Because with 1 gigabit ni, we can use DMR, and then because rural ni, as you know, we don't have the economy of scale. You don't have
Yeah.
a huge volume of user. So who's going to pay for the infra, right?
Yeah.
And then if we use the normal wireless, macam those Wi-Fi kampung, like 10 Mbps, it's very hard to share. Right, right
Yeah.
now we're talking about high bandwidth application. So we need to have a gigabit data speed to rural areas so that we can have what you call this infrastructure sharing, right, along the network path. For example, in rural, if we have like 100 kampung, so we provide connectivity for that 100 kampung, right, through network hopping. So if we can get that gigabit, right, then with that 100 kampung, we have the economy of scale lah. But the issue with current network connectivity for most telco, they don't allow you to do network hopping.
Yeah.
Because when you do network hopping, it is going to what you call this degrade the data speed lah. That's why you look like macam fiber, right? You have the central office, right? They need to reconstruct back the signal.
Yeah.
Same goes with 4G and 5G, right? So most telco punya setup, right? They won't what you call this use the 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 configuration of network hop lah, because network hop for telco it will drop. This is where we design VOLANT to address that problem so that we can have network hop. Network hop without degrading the data speed. Of course, the data speed will degrade, but it not that significant lah. So the data speed degradation is based on the range lah, rather than the way how network works for network hopping. So I see this is the solution, especially not for just Sabah, but for also for Sarawak and also part of Peninsula, right? Those rural areas, because no telco will provide that connectivity because you don't have the economy of scale. But then we have this VOLANT. Why not we address that economy of scale by infrastructure sharing? Right. You hop between kampung or you hop between sekolah, right, or government
Yeah.
office. But to provide the infrastructure sharing, you need to have gigabit connectivity,
Yeah.
right?
Yeah.
So with VOLANT, we address that
Mm.
uh, obstacles. That's why we managed to what call this have a commercial deployment mostly for our
Yeah.
offshore because like offshore, right, you have so many platform, right, scattered around. So we
Yeah.
need to bring gigabit to one point and then we hop from that main platform to other platform so they
Okay.
can bear and share the cost of that infrastructure. That's how we create
Mm.
economy of scale.
And you're not depending on certain technology. For example, you can still work universally for fiber optic, satellite communication, and
Yes.
yeah, and but the backhaul
Hmm.
is a radio signal. Am I right?
Look,
Yeah.
the
Uh,
this one actually it can be any type of communication,
uh,
but we prefer to use wireless because
wireless.
for low cost, easy deployment, right? And then what you call this, you are being regulated by the 30 megahertz
Exactly.
what you call this transmission bandwidth lah. But that's okay. But with how to overcome that limitation, this is where we get this channel bonding lah. But then, like for other commercial solution, there are also similar method of channel bonding, but they need what we call this a pair device lah. That means if I want to have a channel bonding, right, I can be between my own premise lah, or
Mm.
within my own office lah. I cannot have channel bonding. Say I want to connect to YouTube, or I want to connect to Netflix. So VOLANT address the problem. That means you are not limited the channel bonding to another what I call this device lah with similar capability. So that's what how VOLANT differentiate because it's a single client channel bonding.
Okay.
Mm.
Okay. Because you can work on any infra.
Mm.
So, for example, we were in this faculty want to deploy the VOLAN. So
Mm.
the existing infra is there. So the deployment, what are the hardware or, for example, uh, fiber optic, they got the fiber optic cabinet, for example. So what do we need
Mm.
to have to install in this place before we can enjoy the VOLAN connectivity?
Ni VOLANT connectivity ni actually currently I'm using
Mm.
a hardware lah so that we
Hardware.
can put our algorithm. So the
Mm.
hardware currently we are using is MikroTik hardware lah. And
Mm.
then you have to do a lot of what you call this firmware change lah so that it would function as what we wanted lah.
Mm.
So actually the algorithm we have ni it doesn't mean that it can work on MikroTik hardware. It can work with other hardware
Mm.
provided that the
Mm.
manufacturer open up the firmware lah so we can put
Mm.
our algorithm.
Algorithm, yes, yes.
Uh, so VOLANT actually is an algorithm that controls how the data can be sent through multiple path without what you call this having all these packet loss and then you have what you call this reliability issue. So
Mm.
VOLANT algorithm address that uh, problem lah.
Okay, 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 okay. So, we found that it is very
Mm.
interesting and impressive innovation by Petronas R&D. So we are looking for further development or maybe collaboration since you have started working with the Sabanet. So any possibility that for future research, for example, in this technology, VOLANT technology, for the next generation network, for example, possibly.
Because the way we see it something like this lah VOLANT I give example lah you know 5G. Right.
5G, yes, yeah,
5G,
5G.
5G actually is a channel bonding of
Yeah.
4G lah.
Okay.
Because if you look like how they get the gigabit, right, is that they're using 4 transmitter. for what you call this downlink, right? And what you
Uplink.
call this two transmitter for uplink.
Uplink.
Right. So actually it's a channel bonding. But then like 4G, like 5G, right? It use very large bandwidth, and that can be a problem lah. That's why look at 5G, right? You cannot have what you call this transmission range more than 1 kilometer.
Okay.
That's why you look at 5G, you can have like 500 meters because you're going to interfere
Yeah.
other radio frequency,
Yes.
right? So using that concept, right, we can use VOLANT. Say what if we can enable 6G network, right? By not what you call this developing new infrastructure technology, but using existing infrastructure technology.
Okay.
So that kind of collaboration we can have what you call this pursue lah, and then probably
Mm.
we can showcase with VOLANT we can solve problem of campus coverage, for example.
Okay.
Right now if you like a campus, right, you don't have that connectivity, right?
Mm.
If you go, there's a lot of all these blind spot and dead zone coverage lah, right? So we can use VOLANT to address that problem. So once we have that network coverage without any blind spot, without any more
Yeah.
dead zone, right? So you can implement many digital application.
Mm.
For example, you can improve your surveillance, right? You can use wireless camera,
Okay.
no more cable cost, expensive cabling cost, right? And then you can put all those IoTs,
Mm.
right? And then in the future, if you're talking about IoT, right, people talk about LoRa, right?
Mm.
To me, like LoRa is very low data rate. It's not what I call this a lot of advantage that we can use except for the range lah. But then with VOLANT we can do network hop. That means we extend that coverage, right? So we can have high data speed for video application, right? We can do a lot of video AI. We can lot of do of all those AI sensors to address the what I call this the issue lah of what I call this automation lah for what I call this for town operation, right, or factory operation, that kind of scenario lah.
Okay. Thank you, Doctor. I need to read. There are a few questions from
Mm.
the audience.
Okay.
Thank you for this is from our lecturer, Dr. Notin Saad. Thank you for Dr. Interesting sharing. I was told that the government spent 1 million
Mm.
for deploying one VSAT to give internet connection for rural in Sabah with limited bandwidth. How much the cost if we use the VOLANT? Okay, so there's economic issue here.
Hmm.
Okay.
Okay, like I can tell you lah, if like VOLANT, right, the cost of VOLANT actually is quite cheap lah, because it's what I call this is a channel bonding technology, but we have to put in terms of the cost of the infrastructure lah. So I give an example lah, like VSAT is kind of expensive lah, but now we have another alternative like Starlink, for example, like so the way I see, right, you don't need a lot of places to use Starlink. You just need one location to use Starlink, and you extend that network using VOLAN. So that you can bring down the cost. Maybe I give you example lah. Uh, Maybe it costs less than say 100,000 ringgit with the multiple Starlink, and then you extend what I call this the coverage using DMR. Right now there are a lot of cheap DMR in the market that we can use. So you can use that to extend that connectivity lah, from using Starlink from one point, and then you want to extend to other place hop. And then you can use VOLAN Wi-Fi to provide that last mile coverage lah. Example like campus coverage or school. So it's going to be very cheap lah. I give you example lah. VOLAN cost from our deployment, right? Typically between 110 to 120 of fiber optic cost.
110.
110.
110. Okay, very.
So kalau fiber optic to give you gigabit right is 1 million, so VOLANT cost about like 100,000.
Okay.
The infrastructure cost with the same what I call this range lah.
Oh, okay, okay. So it covers both the last mile and the backhaul connectivity.
Yes.
Okay. Okay, another question. VOLANT is a router that it requires special routing or use the available protocol, routing protocol. Is it VOLANT already, of course, patented,
Okay.
right?
Okay.
Yeah.
Okay. VOLANT is patented in terms of the algorithm, but VOLANT does not introduce any protocol lah,
Okay.
because it needs to work with what I call this existing infrastructure, right? So VOLANT does not introduce any protocol. It use the standard internet protocol. So that's why it can work seamlessly with other network equipment. It can go for fiber, it can go for wireless, it can go for even fiber optics. So it does not introduce any protocol. So and the router actually it can use any router provided that router provide firmware access that we can put our algorithm.
Okay, okay.
So it needs to control how the data
Protocol.
transmission works lah. So currently we are using MikroTik because MikroTik allows us to change the firmware. Last time we tried to use Cisco and then suddenly Cisco put a stop. They don't allow us to make any changes.
Okay, okay, okay.
So we are talking with multiple manufacturer lah, like Teltonika, which they going to open up lah, so we can put a VOLANT inside their devices.
Um, we learned that there's interference, right? If we
Hmm?
don't put the high rise between this
Hmm?
transmitter and receiver.
Hmm?
So, do the VOLANT also experiencing the what they call a diffraction because of the interference of high rise of water? What to this
Yes,
allowed?
okay.
Yes. Okay.
Something like this. This is good question.
Yeah.
Okay, like any normal wireless communication, you're going to have the interference, right? So what VOLANT is doing, it controls how data can be transmitted through the channel. For example, I give example. Say you have interference on wireless, right? From one channel. So what VOLANT will do, it will try to control the number of data packets that can be route through that channel. So because it want to minimize packet loss. So that's how it controls. But then, as you can see, that VOLANT can, what I call this, perform for unequal channel performance, right? That means it is so smart enough because the data packet has been cut into smaller packet, so it knows how to send the data through what I call this channel with all these constraint and condition lah, up until to the destination endpoint. So it gets all the information of how to send the data. So we already have that experience lah, for our offshore deployment, right? During apa ni bad weather, so seems that VOLANT performs very well. How it handles the bad weather condition, because it cannot control the wireless equipment, but it can control how the data should be transmitted through the equipment.
Yes.
So you will experience that you don't have that data connectivity loss lah.
Okay. That's how they avoid the no lah the data loss.
Yeah.
And this the IP is belong to Petronas, right? Am I right?
Yeah, yeah,
Yeah,
we only find the
pattern.
method lah.
Okay, 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 okay. Any more question from the audience? Thank you, Nordin.
Maybe I can give a scenario lah. Macam bola ni, I
Yeah,
think good scenario lah. You know highway, right?
yeah, yeah.
Highway kan kita ada toll semua, right?
Yes.
Okay, bola ni something like this lah. When you send a data, right? Usually we talk about apa high data macam apa ni video, right? And then if you apa ni give a visualization lah of this data, say like normal data over the internet macam video, you send like macam besar lori lah, right? And then if that lorry you pass through a highway ni, dia akan being affected lah, right? By the number of cars, by the number of apa ni, tolls. So it will slow down, right? Dia punya performance, right? Okay. Volan ni daripada lorry tu dia split into smaller packet. That means it split into motorcycle with the same payload. You know like motorcycle lah, there's no kind of obstruction lah. Tol pun dia boleh lepas, right? Even jam pun dia boleh find corners lah, right? To pass through. So that's how Volan works lah. Dia make the packet small so that it can pass through other router device lah. Tak kisah any brand without putting a lot of apa ni kata ni obstacle lah. Because when all routers, commercial routers lah, if you see the data packet is small, it just give you a pass through without try to put you in queue lah. That's how internet protocol works lah. If your data packet is small, it will give you a pass through. If your data packet is big, then it will need to check lah. Do apa ni, this data needs to give a priority or what? So bola ni dia macam dia treat lah most router device lah. It make the data packet small.
Other
So
than apa ni, air laut diffraction, for example the monsoon atau hujan atau cuaca angin tak affected the signal quality?
okay, that can affect the signal quality. But bear in mind, when signal quality affected, but you still can send a data, no? So VOLANT would try send very small data to use that channel. So kalau ada solution, kan, the totally you cannot get connectivity lah. We have that bad weather. But VOLANT ni will try to use that channel by sending very small amount of data. So in other words, right, it try to push the equipment, right, to keep on continue transmit at optimum lah. Because I realize like other solution, right, when you have a this kind of severe condition lah, it will stop transmitting. Like macam bola ni, dia akan keep on pushing. So by controlling the amount of data that needs to pass through, even with the orang kata lowest performance lah. So in other words, it keep on apa ni, make the equipment keep working lah. So in other
Okay.
words, you apa ni kata, we force that for the equipment to apa ni increase the reliability-ness lah. So that's why our deployment in offshore, most our user, they're very happy lah. Even with bad weather, they can still get 100% connectivity lah.
Okay. Any more question from the audience? Or you may type into the chat box. Okay, tak ada. Kalau tak ada question, I might hand it over again to Dr. Samsul. Dr. Samsul. Again, thank you, Dr. Mazlaini. We really appreciate your willingness to share the knowledge and expertise about this VOLANT innovation technology. We really like to work with you. We are keep contacting the Sabanet and how the progress is going on. Maybe for future deployment or maybe future research, we are very interested to join in.
Yeah,
Okay.
can. And this one lah, hopefully our installation dekat ni Pulau Sebatik,
Pulau
so that
Sebatik.
can be a showcase lah.
Yes.
After Raya. So probably we can go there and have a look lah.
Yeah.
And then how we extend from studying into the whole school compound lah using VOLANT.
Yeah. We like to know about that progress. So if you have happen that you are plan or willing to fly over here, just let us know. Maybe we can go and visit that area and do as a case study research for this project.
Yeah, sure.
Yeah. Just keep in touch. Okay.
So I just like to recap lah. So in VOLANT ni actually network for rural area is not apa kata apa ni, it's not an issue anymore lah.
Yeah, yeah.
There always a way that we can extend the network coverage lah.
Yeah. Because rural is as untapped market, but as you mentioned, there's no economic of scale. So most telco are not interested to roll out their infra to this area. So if they are
Yes.
not willing to roll out their infra to this area, for permanently this area will be underserved, and the
Betul.
people there will be sidelined for economic advantage. For yeah.
Yes. And then I can add lah because with telco they don't have the solution that can enable unlimited network hop.
Yeah.
So that's
Okay.
one of the issue that that's why telco actually currently we are working with telco partners like Celcom and Axis. They interested the idea of that we can provide the connectivity for rural.
Yes. Yeah. Yes. Yeah. Okay. Dana, is Dr. Samsul is in around? Okay. Okay. So if no other questions, so I think this is the end of our. Okay, Dr. Samsul is there.
Ni Dr. Tamrin, kita ambil
Yeah.
grup foto dulu. Boleh? Dr. Mazlaini? Ambil grup
Boleh.
foto dulu sebagai kenang-kenangan. Okay, Perdana, everyone, please on your camera if possible. We want to take group photo and Perdana will take the photo lah. Okay, kita ada Puan Syaliza, kita ada Cik Dayang Senandong, kita ada Dr. Mohamed, okay, kita ada Dr. Ashraf kat sini. Okay, kita ada Dr. Tan Sufun, kita ada Cik Sofri, kita ada Dr. Alisa, kita ada Puan Nona, Dr. Fadli pada. Okay, Puan Dana, boleh mula bilang?
Okay, ready ah?
Okay,
Smile. 1, 2, 3.
okay, freestyle,
Okay.
freestyle.
Ah.
Cepat.
Okay, 1, 2, 3. Okay,
Okay,
thank you.
okay, terima kasih Dr. Mazlani. Hopefully
Okay.
akan ada kerjasama lah antara Fakulti Komputeran Informatik IMS dengan Petronas lah, insyaAllah. Okay, terima
InsyaAllah
kasih
boleh.
banyak.
Kita boleh
Okay,
arrange
terima
lah.
kasih Dr. Tamrin.
Yes.
Okay, bye. Assalamualaikum.
Assalamualaikum.